So just remember, we're going to do some limits to infinity. So pretty much the same kind of idea as before, but it's really talking about behavior. So we're going to do some more theoretical work of what does it look like. So remember that you got this limit as x goes towards some value of a function is equal to some other value. So remember that this value over here is a y value. This stuff in here is some sort of an expression. And this value right here is an x value. So what we're going to use for this one is c is going to really be equal to either positive or negative infinity in these notes. And then we're looking at what's the behavior of the graph. We're not really going to we're going to talk about what does this look like? What do we have? So we're going to look at the magnitude of functions, comparison, and within that we're going to look at the degree of polynomials. Okay, so within the degree of polynomials, the degree of the polynomial is referring to the highest power of the polynomial. Okay, and there's really three things that can happen. One is if the power on the bottom is greater than the power on top, then the thing goes to the limit is going to be 0. Second thing, if the bottom is less than the top, and we're talking about the power, then the thing is going to either plus or minus infinity. So if the top is greater than the bottom. The third thing that can happen is if the bottom power is equal to the top power, then you look at the coefficients in front of that highest power. Okay, so I know that that's pretty small that I wrote that on there, but there's three different things that can happen with the degree of the polynomials. The power on the bottom can be bigger than the power on the top, then the limit goes to 0. The power on the bottom is less than the power on the top, that limit goes to plus or minus infinity. And when we think about that, we think about does not exist. And then we can, if the power on the top and the bottom are the same, then we look at the coefficient in front of that highest power. So let me show you a couple of examples. Okay, so here's the first one. I pulled these all from Delta Math, so they'll be similar to what you have. So state the limit if the limit exists, and then go on. So if you think about what happens to this particular one, if we were to FOIL out the top and the bottom, notice that if we were to FOIL out the top and the bottom, the only thing I'm really concerned about is that highest power. So if I look at this particular one, the highest power would be to the fourth power, because we'd have negative 35 x to the fourth plus some other things back here, but we get the negative 35 x to the fourth by doing that. On the denominator, we'd have negative 8 x to the fourth plus some other things. Those other things don't matter when you're going towards infinity, because the only thing that matters, if you're putting something like infinity in there, everything besides the highest power doesn't really matter because infinity is so big. In this case, algebraically, whatever that x to the fourth is reduces itself, and the answer is just negative 35 over negative 8, or 35 over 8. Because the power on the top is equal to the power on the bottom, we just look at the coefficient in front of that highest power. That's that third statement that I put up there. So in that case, that is the answer. And that's all you have to do. Okay, so you're just looking at what's the highest power on the top and the bottom. Okay. So let's look at the next thing. Let's look at this one. So let's think about what's happening on this. On this one, the limit is x goes towards infinity. If we think about the highest power on the top is really something along the lines of 5x squared plus some other things. I know that that's fudgy algebra, right? I know that we really aren't supposed to be able to do that. And the power on the bottom is that 4x cubed plus whatever else is there. Here's a case where, because, and the reason is that is x to the fourth is equal to x squared. Okay? So if you look at this, the power on the top is smaller than the power on the bottom. Go back up to the beginning of the notes. When the limit is going to infinity, that means this one is going to be 0 because the power on the bottom is bigger than the power on the top. The denominator is growing faster than the numerator. When the denominator is growing faster than the numerator, then we end up getting 0 for a limit. I know there's a lot of goofy algebra. You'd never do this algebra with anything other than when you're talking about a limit as x goes towards infinity. It's the only time you can do this. Let's take something like this. If we look at this limit, notice that the limit on the top, the power on the top is to the 77th. The power on the bottom is to the 77th. All this stuff over here doesn't really matter. We don't care about that stuff. What we really care about is that we have negative 10 on the top and we have negative 10 on the bottom. So the answer is just 1. Because the power on the top is to the 77th power. The power on the bottom is to the 77th power. When we're taking a limit as x goes towards infinity, nothing else matters because it, in order of magnitude, it just doesn't play a huge part into it. And that 77th power really plays the part. And they essentially reduce. I mean, in all intents and purposes, those two reduce and you get negative 10 over 10. Over negative 10. So let's look at this one. Notice that in this particular one, what we really are doing is taking it as x goes towards negative infinity. So as x goes towards negative infinity, the things that don't matter, let me cross out the stuff that doesn't matter. This stuff doesn't matter because it's not the highest power. This stuff doesn't matter because it's not the highest power. The only thing that matters is the rest of that up there. So take a look at what's happening as we got the limit as x goes towards negative infinity. And notice on the top, you have 3 x to the third, but whatever is in here is always going to be positive because we are going to take it to the 6th power and then take the square root of it. So think about the properties of exponents that we did before. This is the same thing as x to the 6th raised to the 1/2, which is the same thing as x to the third. But remember that everything in there is going to be positive. On the denominator, we have 3x to the third, but because we're going towards negative infinity, this stuff in here is going to be negative. This is a little bit more of a confusing one, but in the end, this one is going to be 3 over -3 or -1. And it really has to do with that we're going towards negative infinity, but the numerator is always going to be positive still because we're still going through these order of operations where we're putting a negative number into for x because we're going towards negative infinity. We're raising it to the 6th power on the numerator. Then we're taking the square root. And on the denominator, we're just plugging in that negative value. So the negative goes away on the numerator, but remains on the denominator. That's why we end up with -1. So think about that. Replay that after you've taken these notes. Replay that and kind of think about what's happening as we're going towards negative infinity. Okay? All right. Write the equation of an asymptote right here. When you think about writing the equation of any asymptote in here, horizontal asymptotes. Horizontal asymptotes are when what the limit is as x goes towards negative infinity of f of x, or the limit as x goes towards infinity of f of x. Okay? So on the top one, we're really looking at the limit as x goes towards negative infinity. And the only thing we're worried about on this function is the 6x to the 5th divided by x to the 5th. On the bottom one, we're looking at the limit as x goes towards infinity. And we're really looking at 6x to the 5th over x to the 5th. The first one, as we go towards negative infinity, we get 6 times a negative value divided by 6 times a negative value. Those negative values are really the same, and so we just get 6. Same thing happens on this one. Those are really the same, so we just get 6. Remembering, this is a y value. So if that's a y value, the horizontal asymptote then would be y equals 6 is the horizontal asymptote. Remember, y equals a number is a horizontal line, so that's the horizontal asymptote to this function. So if you looked at that function, if you graphed this function, and I'd encourage you to maybe go to your calculator that you got in your box at Park Connections and graph that, and you'll see that that graph levels off at y equals 6. Last thing I want to kind of talk about is magnitudes of functions. From least to greatest. So the least magnitude is going to be like natural logs, or the log base b of x, something like those. So that's the least one. Those are going to be less in magnitude to powers. in so powers are going to be higher, but remember powers are affected by one another, that the highest power, so like within this, x to the fifth is greater than x to the second, which is greater than x to like the 1/2 or something like that. And these are less than exponentials. So like 2 to the x power or e to the x power. So the things that grow the fastest is these right here grow faster than these or these. The exponentials grow fastest. That will help on some of the problems when you're kind of thinking about which grows faster. If something on the, if the bottom, so when you're talking about fractions, if the top grows faster than the bottom, then the thing is going to go to plus or minus infinity. If the top and the bottom grows the same as the bottom, that's when we look at the coefficients of highest growth. If the top grows smaller than the bottom, and then the thing goes to 0. And this is when you're taking, this is only when you're talking about limits. This is only when you're talking about limits as x goes to plus or minus infinity. It doesn't work for anything else. So don't apply this to anything other than the limits going to plus or minus infinity. Go ahead and try the Delta Math assignment. See how you do. Go back and review these notes if you need to.